Okay, today we're doing 5.6, the fundamental theorem of algebra. And your learning goal is for you to be able to solve equations with complex solutions using the fundamental theorem of algebra. Basically, this section is going to be similar to 5.5. The fundamental theorem of algebra basically states that whatever your degree is, that's how many roots you'll have. So this just basically states that your degree is going to tell you the number of roots. And this time we're going to find all of them, not just the rational. So we're going to do just like we did before. So let's get an equation. X to the fifth. All right, here's our equation. First step, write your list of possibles. Plus or minus 1, plus or minus 2, plus or minus 4. You divide all of those by your leading coefficient, and you get your list. Now first, let's talk about how many roots we're going to have. If you notice, our degree is 5. So we're going to have 5 answers. All right, so from your list, you're going to pick one of those possibles to see which one is going to give you 0. I'm going to try 1. Remember, you always bring down your first term. Negative 1. Add going down. Then you multiply. Then you add going down. Then you multiply. Add going down. Oh, made a mistake. You got to be careful that you don't do like I did. Hopefully nobody's using a pen. Now let's get it right. You add going down, multiply, add going down. There. Once you get here, you write it back as a polynomial. Remember, you're going to lose a degree, so that's x to the 4th plus 0x cubed, which you don't have to write, minus 3x squared plus 0x minus 4. So this is what we have. Okay? So from there, we can actually factor this one. So we have x squared, 2 factors of negative 4 to give you negative 3. So that'll be negative 4 and positive 1. And you set them equal to 0. So here we get plus or minus 2. Over here, we're square rooting the negative, so you get plus or minus I. So your roots would be the one that worked, which was 1, 2, negative 2, I, negative I. And those are your 5 solutions. Okay, this particular example says find all the zeros. So anytime it says find the zeros, that means that you're going to change the f of x to a 0. And when you write your answer, you have to use ordered pairs. That's very important because a lot of students miss that. So that means we're going to have 4 zeros when we're done. And we're going to do the same thing, make our list of possibles. 1, 2, 3, 6, 9, and 18. And we would divide all of that by 1. And then just going to test make sure no terms are missing. Test your guessing skills. I'm going to guess -3. Bring the first term down. Multiply, add going down. Multiply, add going down, multiply, add going down. All right, remember we lose a degree. All right. So the one that already worked was the -3. So when you write it as a factor, it's x plus 3. Okay. And then you look at this and see if you could do anything with this. We can't do grouping because it's not going to have a common term. We can't use quadratic formula. So what that means is there is another possible 0. There's another number in that list that would work. So you're going to use these coefficients now, because now we've shortened our polynomial. I'm going to try +3. Multiply, add going down. Multiply, add going down. Multiply. Okay, now we lose another degree, so now we're at x squared plus x plus 2. So far, we had x plus 3 to work, and we had x minus 3 to work. Okay? Now, this part right here is a quadratic. And when we set this one equal to 0, we can't factor it because you can't find 2 factors of 2 that can give you 1. So the only thing we can do is either complete the square or quadratic formula. So I'm going to use quadratic formula. B squared minus 4AC all over 2. So that's going to give me -1 plus or minus 1 minus 8, it's the square root of -7. So that'll be -1 plus or minus I radical 7 over 2. So that actually gave me 2. So when I write my zeros, we have -3, 0, that's 1. 3, 0, that's another. And then -1 plus or minus I root 7 all over, whoa, my screen moved. All over 2, 0. Those are my other 2. So remember that plus or minus counts as 2. So anytime they say find the zeros, we want to write them as ordered pairs. And that's it. So sometimes you may have to do synthetic more than once to get down to your quadratic. Because once you get to your quadratic, you can use quadratic formula or completing the square to help you find the other zeros. So if it's complex, that means that you're going to have that imaginary number. And that's it.